Hello and welcome to this video on series and parallel circuits in AC. Today I'm going to explain to you how they work. Before we start explaining the series and parallel circuits in AC, we're going to go through a quick background of what AC is. AC is alternating current, which means the current alternates between positive and negative, which is represented by the sine wave shown below. As you can see, the voltage goes up to positive maximum, down to negative maximum, and keeps oscillating like this. The expression can be shown as a function of time, which equals the amplitude times sine omega t, where omega is 2 pi f, with f being the frequency. The same theory applies with AC as in DC. The only difference is the value of the current and value of the voltage are changing with respect to time, and these need to be portrayed as a sine wave. As you can see, I've given two examples below this. Ohm's law still applies, and KVL and KCL both still work. When analysing capacitors and inductors, we need to work out the impedance, which gives a resistance value for them within the circuit. Now that we have done our refreshing and understanding of AC, let's talk about series and parallel. A series circuit is a circuit where the current can only follow one path. Current remains the same throughout the circuit at time equals t. This can be represented also as a sine wave for multiple values of t. Even in AC, some of the voltage drops around the circuit is equal to 0 at a point in time. This too can also be represented as a sine wave for multiple points in time. To work out the voltage drop, the total impedance would be needed to be found. Parallel is a closed circuit where the current is able to take two or more paths before joining back together. The diagram shows the current taking three paths in the circuit. In parallel, the voltage through each branch remains the same. However, the current through each branch divides depending on the resistance of the branch. To find the total current and apply KCL to find the current through each branch, the total impedance would need to be found. When adding the total value of a component in a circuit, it is done differently depending on whether they are in series or parallel. In series, resistance and inductance are added the same as capacitance would be added in parallel. And capacitance in series is added the same as resistance and inductors in parallel. I hope this has filled you in on some knowledge of what you need to know about series and parallel in AC. Thank you for watching.